So let us start with the next problem of isometric, in which we are given the front view as well as the left hand side view. Observe that we are given the dimensions in the front view, which we call it as the width, and in the side view, which is the depth, and also the heights are given. We will have to interpret each of these lines correctly. First of all, if I look at this particular inclined line and this particular vertical line, then corresponding to this, that is going from this point up to this point, if we locate, then we find a line over here, and that means this particular portion which is over here, this should be interpreted as the thickness of 15. So far as these two circles are concerned, we can very well see that it is going to be a cylinder, and this inner circle will be obviously the hole in that particular cylinder. This dotted line over here is actually indicating the rib. And why is it dotted? Because of this portion, because we are going to look from the left hand side direction, and this particular portion is in between that rib and the direction of viewing. Ultimately this will not be visible, and so is becoming dotted. Then we have got this particular portion corresponding to this part which is shown here. We have got a projection which is coming like this, going till this point, which has got some circular part, and these lines are actually tangent to it. There are two squares which are shown, and corresponding to them you find that there is a dotted line over here corresponding to the bigger square, and a dotted line over here. That means both of them are actually the square holes. One is of depth 6, whereas the smaller square is of depth, which is full depth, 24. Once this interpretation is through, then we can go for the rough sketch of this particular object, which is going to be a very small sketch. We need not be wasting much time on the visualization of this object, and I am just making a sketch of the object where I am planning to show the details as they appear to me. There is some cylinder, so some cylindrical part is there having some thickness. So this is the cylindrical portion that you can imagine, which has got again a hole into it. Then there is some tangent to this cylindrical portion, and after that there is a vertical part. So this much portion can be easily imagined. Then, so this is related to this particular part and this part. Then this goes in slightly, and from there we have got a shape. If you look at this, there is a straight line up to the cylindrical part, and from there it's a shape like this, which is coming from behind, and there is a circular part to it, attached to it. It has got some thickness, and so this can be interpreted in this manner over here. This portion goes behind, and there is a rib as is seen in the picture, and some portion which is behind, and I cannot show it clearly in the visualization part of this particular object. So this portion which is going behind cannot be shown correctly. There is some curve, then a square hole which is not of the full depth, and there is another square hole which goes through. So we can imagine the object in this manner, and then this is the one which we are required to reproduce in the isometric. Once the visualization is through, then probably our job becomes the simpler one, because now when we actually start with the isometric projection, over here, which is our usual procedure of starting with a horizontal line, you can first of all find out as what is the height. It is 50 millimeters, then 50, and this radius is 28. So another 128 will be the total height. So let us shift that horizontal line slightly below, because otherwise we will enter into some other figure which we have already drawn. So start with the horizontal line and of course a corresponding vertical line, and then in the construction mode itself we are required to draw the lines which are at 30 degrees with the horizontal for the isometric. And so here I will be drawing two lines through the point of intersection of horizontal and vertical, which are making 30 degrees with the horizontal. So these two lines are drawn. And now let us go for marking the different blocks. I have already calculated that the total height of the object, if we again look at the given figure, then we can very well imagine as what is going to be the total height of that particular object. We can see that the height is 50 plus 50, and then below this it is 28. So height can be considered as 128. So if we just draw a block somewhere here, as what should be the overall dimensions of this, the object is to be fitted into a box, then the height is 128. That is what we have calculated. We are required to show the front view and the left hand side view. So from this is the direction of left hand side view, this is the front view direction. So let us measure the total width of the front view, which is 20 plus 6, 26 plus 24, 50 plus 25, that is 75, and plus this radius which is given to us here as 550. So that means this radius is 25. So it is going to be 50 plus 50, in all 100 millimeters. So this is 100. And then the side view, this is front view direction, this should be 100, and the left hand side view we are required to measure, it is 45 plus the radius 28, that is 45 plus 20, 65 plus 8, it is going to be 73. So let us draw the box of 73 by 100 by 128, and the entire object should be accommodated into it. So we have calculated the overall dimensions, and using those dimensions now we will proceed to draw a box of those dimensions. So the front view measures in all 100 millimeters. So point of 100 is to be marked. Then side view measures 73. So align the drafter to that 30 degrees line. It will be better if you measure the distances using the drafter only. So it is 73, that is to be marked. And the height is 128. So we can mark 128. So we get the 3 points. And now let us construct the box fully, in which the entire object is to be accommodated. So we can draw the lines again at 30 degrees. Now every time the distances are to be measured along these 3 lines only. That is our very basic principle when we are drawing the isometric. None of the distance which is in the inclined direction or none of the angle is to be marked directly. Even the angle should be converted to the distance form only. So I am simply drawing the box, the dimensions which we have already calculated. And you can imagine that even after taking the care, we are entering into the sketch that we have already drawn. So this will be the box in which the entire object is to be accommodated. Now let us draw boxes for each part, starting with the cylinder, because if you just have a look at the cylindrical part, then I can complete this corner, and then I know that this cylinder is of 50 by 50, so I can locate its box by measuring 50 millimeters, because that is one which can be shown in the front view. So I am marking 50 millimeters, and simultaneously, as we know that this is a cylinder, we can mark the center of it. So measure 50 in the vertical direction also. I am just drawing the box in which the entire cylinder is to be accommodated. Actually, this is a time consuming procedure, but rather a deterministic one, because you are not likely to make any mistakes, because we are not starting with any drawing part in this particular case. See, there are several ways of thinking or visualizing the particular object. Whichever way you pick up, accordingly you will have to complete the solution. You can even go for the combination, that is without drawing the box. In the earlier cases, previous problems, I have never drawn such a box corresponding to each object. So here the cylinder is to be accommodated. Now let us go for the portion which is a straight portion, which is on the back side of width 15. Have a look at the object once again. So I have drawn the cylinder's box as if it is enclosed in a box. Now I am planning to draw this box which is of 15, and I can straight away just mark the rectangle. I will have to simply find out what is its distance from top, and you can find that this distance center to the bottom of that particular plate is 60 and the radius is 25. So it is in all 85 from top. So if we go back to our figure, then from top I am required to measure distance equal to 85 to get that particular point, and then distance in this direction is to be measured, which is 15 millimeters, so that I can easily complete the box which accommodates the plate portion, of the given object. So simply the construction lines are drawn presently. We are not yet finalizing any of the line for that matter. In a way, a best way to solve the problem. And so this particular plate can be drawn of thickness 15. And now let us locate another part which is present as we see the figure once again. You will find that from this end at a distance 20 we are required to draw a box which is of thickness 30. It is from the bottom until the height which is 35. This distance 20 is to be marked, and then the box can be drawn. So going back to the figure, now this is the portion where we are required to measure those distances. First, the distance 20 millimeters is to be marked. Then from that point we are required to go up by a distance equal to 35 as we have just seen it. and so I am starting with that particular box whose width as seen in the front view is 30 millimeters. So it is 30 millimeters that has been taken, and similarly from the bottom you can measure the same two distances 20 and 30, so that it will be easier for us to complete that box. Very acute way of drawing the particular isometric here. Step by step we are proceeding, not likely to make any mistakes in this case. Using the distances, though there are curved objects etc., we are still enclosing everything into the box and proceeding further. So the box which is going to enclose that projected part can also be drawn very easily. This is how the figure is going to appear after the things are constructed. Now we will shorten the box that is required for the cylinder, because cylinder is not till the full length as such as seen in the side view. The cylinder is having a length as 45 starting from back face, and so we can just shorten the block which we have drawn for the cylinder and draw it of length 45 only. And now here at this point I am going to show you the object not drawn in the isometric as a full object, but I am just going to darken the part which is otherwise not to be darkened, so that our concept will be through as how the object is being constructed at this point. So these are the lines which we are drawing here, and now let us see whether we can actually imagine the object correctly. As the lines will not be clear when we actually see it on the video, now I am going to darken these lines to make the picture very clear, which is otherwise not to be done. I repeat, it is not to be done otherwise. I am just going to show you the lines so that you can imagine it well. So the boxes which I have drawn here corresponding to each part, I am going to darken them so that you will come to know even the relation among these boxes as we proceed with the final projections afterwards. It is very difficult actually to explain all these things by simply writing the book. Here you will have to have the procedure by which the things are actually drawn and even the thinking behind it. The basic purpose of VCD courses is to make use of the audio video medium as such to the maximum extent, so that the things which otherwise cannot be taught in the class on person to person basis can be very well understood when you actually see these CDs. So if you can imagine it, the picture that I have drawn, one or two lines are yet to be drawn, but still it will be pretty clear as we proceed with it. Now here I can see the total width of that particular block. Up to the center line it was 75. And so if I mark 75, somewhere going below it. Fine, so nothing else can be shown. So here I have got the different details of the given object which is to be shown in these boxes. You can find that the cylinder is to be accommodated into this. The backplate portion is to be accommodated in this area, as well as the projected part which is over here, and I had marked the distance as 75 where the rib is supposed to start. Here the distance is given to us, but then it is going beyond this box, so for the time being I am not showing it in details. So now let us start with the construction once again, and this time it will be the concept that will be kept in mind, that I am required to use these boxes to the maximum extent. I will be completing the actual drawing. So our usual construction will now continue, and now just have a look at the object only, the given views, because I will be constantly referring to this figure and I have already shown you the construction. So with that construction only I am going to complete the same view once again, and I will be explaining the things again, but I will not be showing you exactly what I am drawing right now, because I am going to reproduce the same figure. Only thing is, this time it will not be as dark as you could see it. I am starting with the box which has been imagined, which has been calculated, and the width we have already noted down as the height is 128. Then in the front view you can see the total length of that particular object as 100 millimeters, whereas in the side view it is going to be simply 73 millimeters. So you can really proceed with this speed even in the exam, so that the things can be drawn in a faster way. All the lines should be drawn. First of all, the box is to be completed. So if you are drawing it with me, I have already started with horizontal line, vertical line, drawn two lines which are making 30 degrees. On the right hand side 30 degrees line I had measured a distance of 100 millimeters, whereas on the left hand side 30 degree line I have measured a distance of 73. Along the vertical line, that is the height, I have measured a distance of 128, and now I have completed the box, marking the 3 points and then drawing lines parallel to the 30 degrees lines as well as the vertical lines. Then I am starting with the point which is behind I am starting with the point which is behind, that is this point, and going to measure distance equal to 50 so that the cylinder's part can be marked very easily. I am mainly interested in its center, and the length of the cylinder was also known to us, which was only 45. So I will be measuring distance 45 also, and will be completing that part in the top. The plane that I am drawing right now is the one which is clearly seen. This is 45 by 50. So the top plane is drawn first, and then to complete the box, height of that box is known to us, 50 millimeters. So we should be measuring 50 in the vertical direction and completing the box. In a way, a simple straightforward job that I am doing right now, but I am expecting that you are also drawing it with me. So that particular box is now complete, and then let us proceed with that plate whose thickness is 15 millimeters. So we are required to simply have 15 millimeters in this direction. So that is left hand side 30 degrees line, and the height of this particular plate also has been calculated from top, and there happens to be slight calculation mistake in the earlier level. No, it was 85, right? It was center to center 60, and then the radius above it, that is 85 from top, it has to be measured. And then the plate corresponding to it of thickness 15, which is seen in the left hand side view, can be marked. So what is where is our principle that we are starting with, and then I am starting with this 20 mm and then going up by 35. Going up by 35 to draw the block of width 30, which is seen in the front view. Actually, that 30 mm distance is seen in the front view. Even the height was visible only in the front view, and the same distances are to be measured, and the same distances are to be measured at the bottom, 20 and 30. So that the block can be easily completed now. There is hardly any difficulty, because once you mark the points properly, I have marked these 2 points, I have marked these 2 points, I will be drawing vertical lines through these 2 and inclined lines 30 degrees through these 2, and the intersection will give me the particular block. So that block also has been drawn, and now we can actually start with the solution. See, there is a difference. As I often say that you are required to imagine these boxes in mind, but then you should not be generating any confusion because of this. You could have very well started with the cylinder or plate, whichever part you are sure of. So from this view, now let us shift to this view, where I have drawn the same part once again when I was telling you the procedure. Now you can have a choice as from where to start. You can very well start from the plate which is behind and some portion of the block as such. So the lines which are full and final, they can be drawn. Let us have a look at the object once again, where you can see most of the distances. Now this height was given to us as 45, so plate can be made dark up to height 45, and from there it is inclined. Back line also can be drawn, but unless we draw the circle, you cannot draw this line because it is tangential. So we cannot draw this line first of all. We can start with this plate. We can draw this line 20 mm which is visible. There is an intersection. You can see the imagined figure. This particular line can be darkened. This line can also be drawn, height 35. This rectangular plate can be darkened. Then these two lines are going tangent to the circle, so circle comes on priority. And now we have drawn only these portions, like this line, this one, these lines are drawn, and remaining lines are dependent only on the circle. So let us draw those lines and then proceed further. The distances are well known to us now. We have been using or calling these distances again and again. So only that part is to be darkened. So the height of this portion over here is 45. So you can mark 45 millimeters and darken that part. We are sure that it is going to be seen, because unless the sketch is there, you will not be sure of which line is visible, which portion is visible and which is not. So I have drawn that. Then the other discussion has told us that we should be darkening this line which is visible, which was seen. Even the top plate is also to be shown, and the length of that particular top plane is exactly equal to the length of the cylinder. Cylinder is having a total length of 45, and so this should be 15 plus 30 mm, and so we should be measuring 38 millimeters, and when the width was 30, that means it is not a rectangle, it is going to be a square. So that top square can be drawn. Full final, there is nothing new that is to be discussed into it. So this much portion can be easily darkened out of that entire object. And then we said that all the other lines are straight away dependent on the circle. And so let us start with the cylindrical portion which we have, and then after that cylinder we will proceed to the circular part which is there in another block. So now to draw that cylinder, of course the hole into it can be drawn at the latter stage, but we should be drawing first of all the outer circle, outer cylinder, because that is going to give us the help for drawing the tangent. So it's the construction of the rhombus which we have already completed, and now we are required to first of all mark the midpoints of the opposite midpoints of all the sides of that particular rhombus, and those are to be connected. The obtuse angles are to be connected to the midpoints of the remaining two sides, and so this obtuse angle can be connected to the midpoints of the remaining two sides. And similarly, this obtuse angle can also be connected to the midpoints of the remaining two sides. ultimately giving me the 4-center method, that is those centers which are required for drawing the cylinder. It's a 4-center method that we normally call it as. So it is a 4-center method which we will be using to actually draw that circular portion. In the same way, we should be drawing the circular part on the other side, and then taking the intersection point of these lines at the center, we can proceed to draw the remaining portion of that ellipse which is representing the circular part. So one job is through. Now this cylinder is going through, and we are required to draw the curve on this particular face, which is at a distance 15 millimeters, because this is a plate that is meeting the cylinder. So we require a center at a distance 30 so that this arc can be drawn, and also a center on the back because there is going to be a curved portion over here. But instead of reproducing the same construction of the rhombus, we will now prefer to only shift the centers. Now this construction is very important. Shift the centers. You should be knowing what you want to draw, and only the corresponding center should be shifted. I am here just shifting the reference points. First of all, these lines are required, and then shift this center by a distance equal to, first of all, 30 millimeters, and then a total distance of 45. So I am marking these two centers here. Similarly, I will be requiring probably the center for the lower part, but on the front plate only. So this center also can be shifted by a distance equal to 30 millimeters, and the other center also can be shifted by a distance equal to 30 as well as 45, because there is going to be some portion of the back plane which will be visible through that. As the centers are shifted, we are not sure as how much portion of that particular curve will be visible, and so we should be rather cautious while using these centers also. So I am using the center. I know the references also, from which point to which point. I am going to the first shifted center and drawing the arc for those between those two lines, and then I am going to another shifted center and drawing the arc. First part is drawn. Then I am taking the smaller radius, going to the first shifted center and drawing the arc. Second shifted center and should be drawing the arc. Then the center over here, through which we should be again drawing the arc. So this is how the centers will be shifted. This is of course the circle on the back plane, and that portion will not be seen. And now I am required to draw a tangent, and how to draw tangent, that is another question, because from this point it should be tangential. Of course it is going to be through the observation only. There is no other way that any measurement can be taken and the tangent can be drawn. And so we are required to draw tangent from this point to the 30 mm shifted center जो हमारा ellipse है, to that ellipse we should be drawing the tangent. And of course from the back also it will be the similar construction up to the tangent. So this portion can be drawn. And now to complete the cylinder, we are required to draw a common tangent which will be at 30 degrees angle only, and a common tangent over here, but it will be up to the plate only. This is how the construction is to be done. And then we know that this portion should be dark, this curve will not be there, it is a smooth surface, and this curve should be dark because it is visible. This portion is going behind, actually it does not exist, it's a flat plate. And so we will darken that part first and then proceed with the remaining portion. So take the center, only that portion is to be darkened. Now we are sure of where exactly that arc is and how much portion should be dark. So this portion should be dark. Similarly, from the shifting, we know that this portion of the arc should be dark. And then the smaller radius with this shifted center, this portion should be made dark. And with this shifted center, only this much portion should be made dark. And then the cylinder part will be over. Now, the same construction will also be required as we proceed with this plate. And we are given that circular portion which belongs to this particular block here is having a radius of 28, and so we are required to construct a rhombus of side 28 into 2, that is 56. Remember, even if it is some small portion of the circle is to be drawn in isometric, necessarily we are required to construct the rhombus corresponding to the full circle, and then out of that only the portion can be darkened. So it is a rhombus of side 56 which is to be drawn. And then the usual construction should continue of drawing the circle, and of course midpoint of each side is to be found out. So this is 58, so it is 29 is the midpoint, and the height is also, it should be 56, some mistake. We are required to measure in all 28 into 2, that is 56. So this is 50, 56. It has to be shifted slightly. And even the height should be taken as 56. So some calculation mistake here. And then mark the midpoints, which is at a distance 28, and even in the vertical line it is 28. So the center is to be marked, which is representing the midpoint. So the full rhombus has been constructed. This was that shift of 2 millimeters. 28 into 2 is not 58, it is 56. And check the distances once again. It is 28, fine, 56. This was 28, 56, right. Now we are required to join the obtuse angles to the midpoints of the other two sides. So the obtuse angle is to be connected to the midpoint of the other two sides. That was the construction for drawing the circle in isometric. So let us mark those lines and now decide as which portion is or which portion of the arc is to be drawn. Of course, we cannot decide that unless we draw the major portion of that ellipse, because again we are required to draw tangents. And so let us take the radius, obtuse angle as the center and this side as the radius. You can always draw the arc. It is just the construction because we are required to draw the tangents. And then where these lines are intersecting, that as the center. I am quite sure that this arc won't be required, so let us not draw it. Draw the remaining portion because this is going to stay. Take the radius properly and draw that part. I am sure that it is going to be dark also. And now we are required to draw tangents. We are required to draw tangents to this ellipse. One tangent from this point over here. Again will be through observation only. There is no other choice for this. Join it and darken it. And similarly another line which will come, which can be also made partially dark because I am yet to draw this ellipse. And then if we go for the other tangent, then we know that that point is going to be behind and I am required to locate that point from where the tangent should be drawn. That point is exactly behind this at a distance equal to 15 millimeters. So through construction you will have to actually show that point. And then tangent should be drawn from that point to the ellipse. And of course only this much portion of that tangent will be seen, the rest is going beyond it, beyond that 15 mm plate. And also now the portion of this particular circular part which is visible, because it is to be shifted also. So I am required to shift first of all this center by a distance equal to 30 millimeters, and even this arc which is due to the center over here. So even this center should be shifted in by a distance equal to 30 millimeters. And now let us proceed with the darkening of the portion of the circle which is visible. So measure the correct arc radius and darken this portion. Similarly from here you are required to darken only the part which is visible. Also that I will be requiring this reference line here, up to which the arc should be drawn, and of course the common tangent line, because those positions will be the points up to which the arc should be shown. So here this arc is to be drawn up to that line, and then the smaller arc should be drawn up to this line. So the portion can be completed and a common tangent can be made darker. So one more part gets over. Now inside this we are required to have the square whose sides are 30 and inner square is having a side of 15. So let us first of all construct the outer square. Of side as 15. So from center I am marking 15 mm on each side, and from those 2 points I will be drawing 2 vertical lines, full and final, 15 millimeters on each side, because that side of the square is seen. So let us not go for any more construction as such. And so the square on the front face has been drawn of side 30, which is given to us, and this particular square is having a depth of 6 millimeters only, and so you are required to take a depth of 6 millimeters, which is to be marked. So once we take the thickness of 6 millimeters, then we can show the inside part of that square, and we are required to show one more square hole which is of 15. Now to show that, either we will shift this center inside by 6 millimeters, and then we should be drawing the portion of the square which is visible. Technique remains the same. Shift the center by 6 millimeters first. Over there, measure vertically. From that point you are required to measure vertically the distance equal to 7.5, if you can mark it. So mark that distance 7.5 up and 7.5 down, so that the total length of the square is 15, and from that center to the left and to the right mark 7.5 each from that shifted center. So 7.5 and 7.5, and then you can simply draw some construction lines horizontal along the left 30 degrees line as well as the vertical. So those lines are to be drawn, because unless we make sure as which portion of that square is visible, we cannot darken anything. And we find that fortunately the square is visible fully. Now you can darken the lines because it is fully within that inner square. So this has been darkened, the square, and then you are required to check whether between these two diagonals we have a distance of 24, because the total width was 30, 6 is lost here, so this hole will be having a length of 24, but we don't have 24 distance, so that we can draw this line just fully and leave it. This is how the square hole will be drawn. Now let us go back to the portion where we are still required to show the rib, whose center is from this point at a distance equal to 75, and we have already seen in our previous construction that that point of 75 is going somewhere behind the block that we have already drawn. So this is that distance, the center 75, and the thickness of the rib was 6 millimeters, so I will be measuring 3 millimeters. This construction will be required, and then from this lower portion of the circle measure 3 millimeters on either side on that circle, and then these points are to be connected. It is going to be very complicated type of construction, not a detailed one as such. So this portion can be drawn, and so as we can draw the another portion which is just going below it, and I require that left 3 mm wala point jo hai, this point, this is going to be a straight line, only this portion will be visible. This is how it can be drawn, and then from that back point only another rib is going, which is totally behind the object, so that cannot be shown. So we have completed most of the part of this object. What remains is now to draw another circle, which is the circular hole whose diameter is 36, it remains the same construction once again with this as the center. We are required to construct a rhombus of side 36, that is 18 on each side. So measure 18 millimeters on each side, mark the points, then again vertically measure 18 millimeters on each side. So 18 millimeters on each side is to be measured. This remains as the construction only. So the rhombus is to be constructed. And again the same construction is to be done, that is, the obtuse angle should be connected to the midpoints of the other two sides. Obtuse angle is to be connected to the midpoint of the other two sides. This and we get the construction, and complete that particular ellipse in isometric with this 4 center method. And so that the object will be completed. And now to see this object clearly, I am eliminating the construction lines, but those are to be retained. So I am just removing all the construction lines which we have drawn earlier. The portions of the curves which are not required. In the exam, all these construction lines are to be retained, they are not to be removed. see the actual object very clearly. Remove all the construction details, and this is how the object will appear. The object was fitted into